Hi, my name is Ian Fogarty. I'd like to talk to you about alkanes today.
Now we can have multiple branches. So here's a nice example of something with a multiple branch. So here's my parent chain. It's the longest continuous carbon chain without taking my pen off. And then I've got a branch there and another branch there. So I'm going to name it's usually best when we do these to name things backwards, starting with the parent chain. So I'm going to give these branches the smallest possible number. So if I go 1, 2, 3, or 1, 2, 3, 4, okay, 1, 2, 3, 4, 5, 6. So this is a hexane. And it's got two 1-carbon branches. So methyl, 1 carbon, and then branch. And there's 2 of them, so I'm going to call it dimethyl for 2. And I'm going to tell them where they are. This is going to be 3, 3. So off of carbon number 3, I've got a methyl group. Off of carbon number 3, I have another methyl group, and it's on a 6-carbon chain. That corresponds to that. There's my branch. Compare that to down here where I would have my continuous parent chain and then a 1-carbon branch there and a 1-carbon branch there. So I'm going to count 1, 2, 3, 4, 5, 6. This would give me hexane again. It's going to be a methyl branch and another methyl branch. And this time it's going to be, and there's 2 of them, so there's di. And now it's 2 and 4. We put commas between the numbers, we put dashes between numbers and letters. This is all one word. 2,4-dimethyl hexane. So the hexane corresponds to the parent chain. And then there's my branches. So I'm going to find the longest continuous carbon chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it doesn't matter which way I go. I can go this way, or I can go this way. It's going to be a tie. I'm going to choose to go this way. And that means I have a 1-carbon branch there, and I've got a 2-carbon branch right there. I'm going to give the largest branch the smallest number. So I count this way, 1, 2, 3, 1, 2, 3. So it's a tie. If I go this way, the branch is at carbon number 3. If I go this way, the branch is at carbon number 3. Which one will win? The answer is give the biggest branch the smallest possible number. So I'm going to choose 1, 2, 3, 4, 5, 6. So again, we have hexane. Now, off of carbon number 3, we have an ethyl group. So 3-ethyl. And off of carbon number 4, we have 4-methyl. So there's one option. The other option is to do it this way. This is a hexane. Could I call it 4-methyl? Start with the smallest one. I already know the numbering. The numbering is not going to change. But when I write it down, do I start with the smallest one and end up with the biggest one? Or do I start with the biggest one and go to the smallest one? Both of those would be reasonable, and both of those are wrong. It turns out that when I'm numbering them, I'm going to give the biggest branch the smallest possible number. But when I'm actually writing them out, I'm going to put them in alphabetical order. And so E comes before M. It has nothing to do with how many carbons. It has everything to do with alphabetical. So this is the correct one right here. Not because ethyl is bigger than methyl, but E comes before M. And I wouldn't worry about that one. Okay, looking at this one, how do we name this? So first thing I'm looking for is the parent chain, which is the longest continuous carbon chain. And there's some different starting points. So I go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. That's shorter. 1, 2, 3, 4, 5, 6. That's shorter. 1, 2, 3, 4, 5, 6, 7. Oh, that's a tie. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it looks like I can continue along, but I have some choices. I could go this way or I could go this way, and it doesn't appear to be any difference. So let's go just for kicks and choose that one. And now I'm going to identify what my branches are. And so I've got a 1 carbon branch there, I've got another carbon branch there, I've got another 1 carbon branch there. So those are my methyl branches. And then here I've got a 2 carbon branch and another 2 carbon branch there. And that's all my branches. So to try and figure out how to number this, do I go right to left or left to right? I'm going to worry about my 2 methyl branches, sorry, my 2 ethyl branches, give them small. So if I go here, 1, 2, 3, 4, 5, 6, 7, that's great. And just to check, we'll do this in red. 1, 2, 3, 4, 5, 6, and 7. If I go by the black numbering, I end up with a ethyl group off of carbon number 3 and carbon number 4. If I go by the red numbering, I end up with a carbon 4 and 5. So it looks like the black numbering is what I want to use. This is going to be heptane. Kind of start at the back and then start moving forward. So I'm going to have, let's go with ethyl. And there's going to be 2 of them, so diethyl. 1 off of carbon number 5. Carbon number 1, 2, 3, and off of carbon number 4. And now I can do my methyl groups. One's off of carbon 3, 4, and 5. So 3, 4, 5, trimethyl heptane. And so this would be all one giant word. There'd be no spaces here. If we look at this one and we pick the longest continuous carbon chain, we would have to pick this as the longest continuous carbon chain, which would be great. And then we'd have a branch. And then off of that branch, we'd have another branch. And so we'd have branches off of branches. And we're not going to spend very much time talking about branches off of branches, but there are a few examples that show up all the time in biology and in chemistry. So we're going to spend some time doing these focus ones. So here's our longest continuous carbon chain, and then we've got 3 examples of branches off of branches that show up often, and we're going to focus on these ones. And so this one is propyl, 1 carbon, 2 carbon, 3 carbon. So it's a 3 carbon branch, but instead of being attached on the end, it's attached in the middle. So this is going to be called isopropyl. This one is a 4 carbon branch. There's 4 carbons. But again, it's not attached to the end. It's got this kind of Y shape. It's going to be called isobutyl. And last but not least, we have another 1, 2, 3, 4 carbon branch. If this is in the shape of a T, it gets the symbol t-butyl. Now the T here doesn't have anything to do with T there. It's really short for tertiary or tert butyl. But it is a nice way to be able to remember that t-butyl looks like a T. Okay. So those are our special branches off of branches that we're going to focus on. That concludes our introduction to organic chemistry and alkanes. And we're going to have many more videos about other things coming up. Thank you very much for your time.